Hey everyone, welcome back to the channel. In this video, we are going to cover Module 1 of S4 Maths in a very simple and exam oriented way, with clear explanations, important theory questions, and easy problem solving techniques. If you are preparing for exams and want guaranteed marks, this video is for you. Let's get started. Define a graph. A graph is a mathematical structure used to represent relationships between objects. It is defined as an ordered pair G is equal to VE, where capital V is a non-empty set of vertices and capital E is a set of edges connecting pairs of vertices. Graphs are widely used to model networks such as computer networks, social networks, and transportation systems. What is the order and size of a graph? The order of a graph refers to the total number of vertices present in the graph, while the size of a graph refers to the total number of edges. These two parameters give basic information about the structure and complexity of a graph. Define finite and infinite graphs. A finite graph is a graph that has a finite number of vertices and edges. Most practical graphs used in applications are finite. An infinite graph, on the other hand, contains an infinite number of vertices or edges and is mainly studied in theoretical graph theory. Define degree of a vertex. The degree of a vertex in a graph is defined as the number of edges incident on that vertex. If a loop is present at the vertex, it contributes 2 to the degree since it connects the vertex to itself at two ends. Degree helps in analyzing the connectivity of a graph. Define handshaking lemma. The handshaking lemma states that in any undirected graph, the sum of the degrees of all vertices is equal to twice the number of edges. This is because each edge contributes exactly 2 to the total degree count. This lemma is useful in solving problems related to degrees and edges. Define isolated pendant and null graph. An isolated vertex is a vertex with degree 0, meaning it has no incident edges. A pendant vertex is a vertex with degree 1 and is connected to the graph by only one edge. A null graph is a graph that contains vertices but no edges at all. Define walk, path, and circuit. A walk in a graph is a sequence of vertices where repetition of vertices and edges is allowed. A path is a walk in which no vertex is repeated, ensuring uniqueness. A circuit is a closed path where the starting and ending vertices are the same. What is a connected graph? A graph is said to be connected if there exists at least one path between every pair of vertices in the graph. Connected graphs ensure full reachability among vertices and are important in network connectivity analysis. What is a component of a graph? A component of a graph is a maximal connected subgraph. This means it is connected and cannot be extended by including any additional vertices or edges from the graph without losing connectivity. Define subgraph. A subgraph is a graph formed from a subset of vertices and edges of a given graph. The vertices and edges of the subgraph must be taken from the original graph and their incidence relations must be preserved. Define graph isomorphism. Two graphs are said to be isomorphic if there exists a one-to-one correspondence between their vertex sets such that adjacency is preserved. Isomorphic graphs may appear different visually but have the same structural properties. Difference between walk and path. A walk allows repetition of vertices and edges and is the most general form of traversal in a graph. A path is a more restricted form of walk where no vertex is repeated, making it simpler and more structured. Difference between connected and disconnected graph. In a connected graph, every pair of vertices is joined by at least one path. In a disconnected graph, there exists at least one pair of vertices for which no path exists, resulting in a separate components. Finding number of edges from degrees. Using the handshaking lemma, the sum of degrees of all vertices is calculated and divided by 2 to find the total number of edges. This method ensures accuracy since each edge is counted twice in a degree sum. Odd degree vertex condition. A graph cannot have exactly one vertex of odd degree. According to the handshaking lemma, the number of vertices with odd degree in any graph must always be even. Sum of degrees. The sum of the degrees of all vertices in a graph is always twice the number of edges. This relationship holds for all undirected graphs and helps verify the correctness of degree data. Pendant vertices in a tree. In any tree, there must be at least two pendant vertices. This property arises because trees are connected and acyclic, forcing at least two vertices to have degree 1. Graphical degree sequence. A degree sequence is said to be graphical if it is possible to construct a graph having those degrees. A necessary condition is that the sum of the degrees must be even, as required by the handshaking lemma. So this completes module 1. We have covered all the important theory questions and solved problems in a clear, exam-oriented way. If you have revised these concepts properly, you can score confidently in your exams. If this video helped you, don't forget to like, share it with your friends, and subscribe for the next module. See you in the next video. Bye.